some way defined once you start your application, your custom ROS package, whatever you're trying to write. This has benefits and it also has some downsides. When you, for example, want to write a very simple application to acquire sensor data, and your sensor is publishing data in a certain way, for example, according to some specific ROS coordinate frame, you can have NED or EUW, for example, according to the information that is provided from your IMU. And ROS2 node life cycles allows you to define the way that your node works and your parameters work without having to kill the application. So for example, if you are starting your node for the IMU and you want to acquire the data at a specific frame rate, for example, let's say 100 Hertz from the IMU, and for some reason then you need to update the way that your sensor data is being acquired, you can do that without having to restart the entire application and without having to restart your node and your system in general. So ROS2 introduces the concept of lifecycle nodes, also called managed nodes, and this system allows you to ensure that all the requirements for your application to run correctly have been started. Okay, so if you need, for example, to have some connection with your sensors, with your hardware, it allows you to do the proper configuration, and the nodes also can be restarted on the fly without having to restart the entire application. ROS node life cycles also follow the
technical issues. Cusarion is also a company which develops robotic-based platforms here in Krakow. Their robots can be found around the world within many universities and companies. If you consider any application which is based mainly on something which should get from point A to point B, you should check the Cusarion market offer. Also, I would like to warmly to thank you my workplace, which is the Center of Excellence in Artificial Intelligence, which provided us a spot from Boston Dynamics to warmly show you what today's technology is capable of. Without more nuances, I want to inform you that we got some switch between our speakers. First, we go Georgi Dudnik with his robot. Sorry. And after a short break and a beer time, we will welcome Jakub Jurzak with his presentation about the drones. If you have any questions, probably it's a good time to grab some beer and start to listen. And after our first speaker, there will be a good time to ask the questions to us as the organizer. So I would like to ask you for a round of applause for the speaker.
Thank you.
And the stage is yours.
Thank you. Thank you. Nice. To run cards, which is the biggest, most powerful graphical card in the world. Every of that piece costs like about $35,000. Every of the 9. Or we can use 34 of FX's 4090 to run again simultaneously on them, the most powerful GPU available on the consumer market. So, I'm Grigory Dudnik, and today I will tell you how we can run the large language models on the single Raspberry Pi. But before we will dive into actually how we can run the LLMs on Raspberry Pi, let's maybe talk why we want to do it. So, you guys, I think, sitting on some robotic stuff, many of you attended to science circle of robotics in AGH, I guess. Or at least interested in the topic. I see some people here. So yes, actually, the robots currently, at least at my understanding, well, very advanced robots can do like, I don't know, can fly, can swim, can go in different terrains. There's robot waiters and robots that clean in your room. But still, most of them, actually all of them, are either based on the simple algorithms. Their control algorithms are based in some if-else loops, or maybe some simple neural networks. And their decision-making process is relatively straightforward. If your cleaning robot hits the wall, it goes right. If it not hits the wall, it goes right. And that's actually all. In my opinion, if you want to create a robot that can have a lot of different things to do, can have a lot of tasks, and should be able to operate in unknown environment, for example, as a rover in the Mars, which should be able to make different decisions what to do in that moment. And for example, that Mars rover could go to continue his mission and gather new minerals, but risking that his will end and he will not return to his base, or he can break his mission and return to base to load up the battery again by the cost of the breaking his mission. So, in case of such complicated decisions, not obvious ones, the simple if-else algorithms are just not enough. We need to make our robot be able to think, to weigh different possibilities, pros and cons of every option to make that best, not obvious, hard to do decision. And single way to do it without the human interaction is to use LLMs. Yes, large language models actually are able to write text to make decisions, but the problem with large language models is that they are large. They're large, they require big GPU to run them, which weighs a lot, costs a lot, and consume power a lot. As you can guess, such GPUs are totally not suitable to place them in the mobile robots, and that's why if we only will be able to somehow place the LLMs on such small thing as, for example, Raspberry Pi or maybe some other microcomputers as NVIDIA platforms, for example, in my opinion, it will be breakthrough. We will be able to create the robots that are able to think, make complicated decisions, and be able to autonomously operate in hard conditions. Yes. So that is why. And now let's discuss actually how. So, in order to run our model, our large language model, in such small platform as Raspberry Pi, we need to do a few steps. First of all, we need to choose appropriate model. Not all the models are equal. More precisely saying, not all the models are equal sized. And while the top models, as earlier said, Llama 3 with 405 billion parameters has that hundreds of billion parameters, there are a lot of small models as well that contains, for example, 7, 8, or even less, 3, for example, billion parameters, and still they are quite good performant. they are obviously they're less intelligent than the top models, but we can say that models which are, for example, 50 times smaller, they're also 50 times less intelligent. No, you can see, for example, to such parameters as MLU, ARC, and GPQA, which is just metrics of intelligence of our models, and compare that metrics for Llama 3.1 with 405 billion parameters and Llama 3.1 with 8 billion parameters, which is 50 times smaller. And we can see that obviously the smaller model is also less intelligent, but it's not 50 times less intelligent. It's just somehow less intelligent, but still it's comparable. Okay. So first of all, we choose an appropriate model with 7, 8 billion parameters or even less. Second thing we're doing is quantization. So quantization, as here earlier been said, is the maneuver allowing us to reduce the size, maybe not the actual size, the size of every parameter inside of our model. So, for example, our model by default, every of the 8 billion parameters had size of 16 bits. So by quantization, we're reducing it to 8 bits or 6 or even 4 bits. So our model also became much smaller and require much less computational power. Unfortunately, also there's a cost of also losing an intelligence of that model, but that drop in intelligence is much smaller. Oh, my computer is always saving his battery. So the drop in the intelligence is usually much more smaller than the drop in the size of the model. And third thing we can do is the fine-tuning of our model. The fine-tuning, yes, about this we'll tell maybe more in detail later. So fine-tuning is a trick allowing us to increase to pre-train our model is in concrete set of data we created exactly for our use case, and after our model is trained, and after that our model will be trained exactly for that use case and will be very good in that concrete use case, will increase its intelligence for that concrete task, for example, for task of being, let's say, Mars rover, but on the rest of the task it will be still like same level of intelligence as before. Yes, so so let's talk about fine-tuning, and yes, and after that I will maybe show you a demo if that robot will work after all my trip from Katowice here, because you never know. Okay, any of you, by the way, heard about fine-tuning, maybe done some, or I see here, okay, maybe you want to share your experience with that trick, how did you felt about it?
It depends how big the model you would like to fine-tune, because it would cost a lot of money.
Mm-hmm. Oh, let's say 8 billion.
I don't know how it could be, but I would use, for example, Google Colab to get computation power.
Yes, actually, even in free version they have, I guess, 60 gigabytes of RAM.
Yeah.
Yes, and actually I actually also tried with Google Colab, but had some problems with, I don't know, with some codecs or whatever. And for some, it should work, but for some reason it don't. So that's why I decided to buy RTX and fine-tune, but doesn't matter. So yeah, so it's very fun stuff to collect your own dataset and train your model in your specific dataset. Yes, and actually, I'm thinking if I have the example in my Raspberry Pi of the Mars rover actually demo. Give me please a while. Maybe I will find it. Maybe not. Because if I find, I will show you. Could be. Okay, never mind. Not this time. So actually, the project I want to talk to you about that actually the fine-tuning of a robot to be a Mars rover, to be able to make decisions where to go, which side to return to the base, or maybe to go to explore some materials. On depends of what his camera sees. So we provide him to LLMs what's going on actually around him, and our robot writing a reasoning and decides about direction where to go. So yes, we will talk about fine-tuning. So point is that in that case I can just train the robot on the data of different input situations. Like for example, on the front of Mars rover you have some dust storm. On the right side you have craters. On the left you have clear space. On the rear you have rocks, and you need to make decision where it's better to go, which side will be like more will be optimal direction. So yes, so here yes, so here actually we gathering a data. Yes, okay. Before I will tell you how we do it, actually, let me tell you something more about why we want to do it. So first of all, we're increasing as I said previously, increasing the level of intelligence of our model for that concrete task. So even small model could be even more intelligent than, for example, GPT-4 in that concrete task. And second thing, it also allows us sometimes to shorten our prompt. And by shortening the prompt, it can also reduce the size of required RAM to run that model. So actually, by shortening prompt, I mean that normally, for example, we're asking our robot that you're Mars rover, you blah blah blah, do that, and on the end we provide him instruction that return your output in JSON format. But when you train your model with data that contains only the JSON in outputs, if you by default know that it should return in JSON format his output, and you don't need any more to write the text in the prompt. The shorter prompt, the faster working your model, and the less RAM it requires. Okay, so how to do the fine-tuning? First of all, we need to create the data for fine-tuning. How to do it? Well, obviously we can write the examples from our hand, but it's better to use some more intelligent model, as GPT-4 or whatever, to write the data for you. By the way, it's just for very beginning of your fine-tuning, 100 examples is enough to do something, but for production application, it's better to have like 200, 300, 500 examples at least. So how the process look like. You describe them for the model the situation of the data what they should generate. So please generate me data for the Mars rover. The data should be like the rules of the game that it could have, that dust storms, clear spaces, rocks, whatever on input. After that, it provides a reasoning about which one of which side is better, and after that, it generates decision. So you described that. You described which direction is better over which, and asking it to generate 100 examples for you, and job is done. No, it's not working that way. Unfortunately, you're asking it to provide you 10 examples, and it writes 10 examples of such JSONs you can see here. And after that, you check in manually every of that examples, correcting mistakes, a lot of mistakes GPT will do manually again, correcting the reasonings, correcting outputs, and after that you're asking it again, maybe provide some feedback that okay, now you writing too much about clean spaces on the front, please provide more crafters on the input data, for example. You provide some feedback and asking it to write another 10 examples. Now, when it have good 10 examples on its context, the GPT will provide you a little bit better than next 10 examples. But again, you will need to check it manually, correct all mistakes, and again ask it to provide next 10 examples, which be again a little bit better, and again and again and again. But and like after a few iterations, examples it generated will be much more better. But still it's never like guaranteed that they will be ideal, and still you need to check every of the example manually if it makes sense. Also, you can try to introduce some different automations. What do I mean? I mentioned that GPT when generated such data very often has bias on the input. By bias I mean that very often it just writing some low rocks, for example, the storm, clear space, but rarely writing about craters. And I decided, what actually should I ask GPT to write that input data when I can just create a Python script that will randomly generate the data, that input data for me, and ask GPT only to generate outputs for the provided input data. You get it? Such way we making our system resistant to that GPT biases and actually automatizing part of the LLM's work. Yes. Okay, so we created data for our training. Next we need to make the fine-tuning itself. So here you need to create a script that making your fine-tuning process, and it's been, to be honest, quite complicated stuff. I remind for myself the times when I've been doing some training of deep neural networks, when you have thousands of different parameters to set up, in case of 90% of which you have totally no idea for what they are needed, for what they are needed. So here my advices for you. For example, use an Ansible library instead of standard libraries for fine-tuning. That library, first of all, making your fine-tuning faster, but in fact, in case of when you have just 100 examples, it not like takes you like 1 or 2 minutes. So it's not the case in that situation. But what is the case, that the library actually allows you to very much simplify your code, to make just fine-tuning script with the Ansible library is much shorter, and also it provides you with a lot of utilities, allowing you to simply export. Simply export your model after the fine tuning in the needed format to run. Be careful also with quantization, because after you've done fine tuning, you will probably want to quantize your model to make it smaller. And very often, surprise, surprise, when your model in full size been working as intended, it stopped work unintended after being fine tuned, because it's smaller and less intelligent. So yes, remember about it. And also use Olama actually to run the model, because it's a very convenient way to run models. You can convert your model with GGF format to Olama and run. Yes. So, okay, let's make a demo time and run our robot. Who want to see how the robot will work? No. No, okay, we can skip the part. I'm running my Wi-Fi and we will see if it works. You know, guys, when you're doing some live demo, things actually stop and work. So, especially when you have not live demo only about programming stuff, but live demo about programming stuff, electronic stuff, and mechanic stuff. So it's like 10,000 times more things that could go wrong. But, well, let's try to do something. Do you have, guys, any idea what the robot will do?
The train? The train.
Yes, it's train, but more precisely.
Left, coming to the right. Is it a simulation of crosswalk?
Trams going out of the track. Not yet. Any other ideas?
The John's.
I hope no. I hope no.
It will obey your command.
Obey my command.
Yeah.
Well, I'm actually not going to give him any of the commands.
Okay.
It will do the decisions by itself. In case it will work, because we don't know.
So we don't hallucinate
for
sure.
Sorry?
What sense of that?
What sense of the robot? Okay. So let me explain you. Do you know who of you knows the trolley dilemma? So yes, trolley dilemma is actually a simple problem which we can't solve just with basic algorithms. It's not any if-else solution for valuing the moral weights of every of the options to go, and only the human or LLM that available to write the reasoning can actually make decisions which will be hard decision, not obvious how to do that, but needed to be done. Okay, so you see my screen, amazing.
Yes.
And it does not work. Let's try again.
The robot is shy.
We'll be right back.
Oh, maybe we have no internet here. Let me connect to my Wi-Fi. That's nice. Okay, maybe we have here an internet, but what about our robot? Looks like it should work actually.
Turn off, turn on.
Sorry?
Turn off, turn on.
Yes, exactly. That's what I'm going to do. Probably we have 2 batteries here, so...
Just a team of ink. Never work.
Yes. Okay, let's give him a minute. Hope it will work.
It feels the pressure from the audience.
Sorry?
It feels the pressure from the
Yes,
audience.
guys. We should... Yes, we should sit
should.
here and he will not feel the pressure.
Well, he has to solve a trolley problem, so people will die.
People will die. Yes.
Okay, it's connected.
It go green.
Sometimes it go green, sometimes it go red. Now it's live.
But at least it means it's working.
Huh?
Probably.
Probably.
Ta-da! Okay. Very good.
Better collect.
Ta-da! Okay. So, let's actually go into our script. Let's give him a minute. He needs to think.
I have a question. In general, what kind of models is possible to run on Raspberry Pi? Are
Yes.
they useful in general? And what is
Yes, actually, it's a good question because that models actually getting much more. The small models, I mean, getting much more intelligent, like every month, every week. Maybe. Oh, okay. Sorry, I will ask it later. Okay. So we have our script. And let's add him a problem. For example, we can provide here on the right side, we'll give a small, polite child. In the left side, we'll give a small child that never listens to his mom. Calm down. Okay. Let's say Let's say it will be good child and it will be child that never listens to his mom. Okay? At the right side, yes, right side is here. I always have a problem with right or left, guys, so sorry. In the worst case, we will just run over the wrong one. And this is that. Okay. So, actually, let's wait a little bit. One of the main issue of running the models, big models on small computers, is that we need to wait. Sorry. Yes, exactly. Feng Shui or whatever. Yes, and they are thinking, they making his internal calculation, they are loading into the RAM, and after that they started generating their decisions in case the robot don't get broken earlier.
First run is only that long, or every run is that long?
First run, yes, takes especially long. It's happened to write the response. So you can see that it outputs actually the XML with and making a reason. First of all, waiting the right arm, so at the right side, the child to die in the trolley to his right, small polite, blah blah blah, implying that they are innocent and not caused any harm, blah blah. Also waiting left arm, the child to die. And suddenly making wait which arm is more bigger. And make decisions. Okay, he make the decision. Okay. Let's do it once again. Or maybe let's do it with another model, because now I took the 3 billion model, which is small, fast, and less intelligent. Now we will take 8 billion parameter model, which is more intelligent. Still not enough intelligent very often, but more intelligent. And we will wait much more longer for that, but I guarantee it will work, and yes, I can answer the questions at that time.
So your base models are all Llama 3.1 and 3.2? Yeah?
Exactly in that case, I used previously in the previous run, I used the Llama 3.2 with 3 billion parameters.
Yeah, very small.
And now I switched to the open chart, which is fine-tune of Llama 3 with 8 billion parameters. With 11 billion parameters. And that fine-tune actually works much more better than original Llama, but unfortunately there wasn't any fine-tune for the Llama 3.2. Yes. Here you had a question about the models, and can you repeat please?
So what kind of models can you run on a Raspberry Pi?
Yes.
The speed.
Yes,
So
actually,
this is speed, right?
yes, the speed is issue, and in my opinion, 8 billion parameters is the upper border, which has any sense to run it actually. In one of the later slides, I will show you the times. But it takes, as you can see, a few minutes even to generate for 8 billion parameter model. The problem, the actual situation looks like even a few months ago, that 7-8 billion parameters model been the smallest models that are intelligent enough to make some more or less intelligent decisions. Now, even the 3 billion parameters already became intelligent enough to do so, which are much smaller and also running much more faster, which is amazing. That I'm waiting when in Llama it will be available that Mistral model from the Mistral to run it with 3 billion parameters, which is according at least the benchmark is much more intelligent than the Llama 3.2. So yes, it's constantly developing, and also the issue is which Raspberry Pi you're actually using. So I'm using the Raspberry Pi 5, the newest, most powerful. And fun fact, the Raspberry Pi 5 is running like 2.5 to 3 times faster than Raspberry Pi 4B.
So what you're saying is 8 billion is like practical limit, right, for this kind of hardware?
For Raspberry Pi, yes. But no, it already running. You can see for 8 billion parameters model, it generated much slower.
Have you already reached out to Polish Railways?
Sorry.
Did you reach out to Polish Railways?
Propose them some solving dilemmas. But, I don't know. So why trains coming too late. We have waiting, and we'll see if it writes something normal this time or not. It seems the would be less than it will have. So you will need a white make a decision right. And our robot is our white child. Well tried. Okay guys, do you have any ideas which code this time we can put on our rails? Something for which we not get banned by organizer, please.
If it's polite but old.
Polite, okay. Small, like small old child.
Small polite old lady.
Small but old.
And polite.
And polite.
Yes.
Small. Okay. Polite old lady. Okay. Left object, guys.
Child with cancer.
Child with cancer. Okay. Small child or just child?
Just child.
Just child, okay.
And the old lady can give you a candy.
Who gives a candy?
If we will not hit she, okay. She give you a candy if you will not hit. No. Ta-da.
I have a question.
Yes, one thing on the very important thing, we need to choose the lady and child with cancer. I don't have any old ladies here. I assume that this is the old lady.
Probably.
She been at the right side, yes?
Yes.
Yes. So this is the old lady and child with cancer, let's say child with cancer. His face like he definitely has a cancer. Yes, so I'm listening to your questions.
Yes. Have you thought of the applications of LLM on Pi? As in, I see we are very tolerant of mistakes here. So we're not going to use it in life and death decisions. But we also have no internet, right? Otherwise we could just communicate with the server. And we cannot use algorithm, we have to use LLM. What is the application that fits all of these criteria?
Yes, it's a very good question actually. I'm still thinking about it. Yes, about the tolerance for errors. Here also using the not fine-tuned model, just straight away taken. But if we fine-tune it, especially for solving that dilemma, I think that also results will be much more better. So we can do a brainstorm later and think about the way we can apply such things. I'm also very curious what we can come up with. The trolley would hit and kill small flight. Old lady who would have given you candy if you had not eaten cow. The trolley would hit a huge child with cancer, causing great suffering to the child and their family. Well, quite obvious. It was to cause unnecessary harm for an innocent person than to end the life of someone who is actually. And child with cancer will be killed.
I can make a comment, which is there is some debate in the community now in academia between making the decision-making problem into an LLM, and it's for now everyone agrees that it's not reliable. It will never be robust because of the hallucination problem and all of that. But in this case, this is not how should I say it, like a simple problem that anyone can solve it with logic. So in this kind of applications, actually, you might have better results because the problem is open-ended, right? This is like a moral dilemma. It's not something you can solve with logic. So that's small comment.
Yes, I mean, obviously, I hope we will be able to use that, and I think it's quite possible to solve also, not more obvious problems, to make that intelligent decision with fine-tuning, with using more intelligent models. So yes, it's actually fun to use that.
But fine-tuning will be biased to the the logic of the person that you generate the data. So it's still not
But you generated data.
So for example, if you gather the group of people that think that killing the old lady is more logical, more moral, correct. So it will be biased to this.
Yes, totally. You can fine-tune your model. You can train it to prefer one group of people over another group of people. So as you wish.
Just to clarify, what I mean is that with LLMs, even like the best model like GPT-4o, what some people that really believe in it, what they claim is that it can reason, but the kind of reason that it does is basically associated with a language. So it's something in philosophy called argumentation. Mm-hmm. So it can reason, but in terms of argumentation. And this is the problems that we have like with politics and all of that, that it's not something that we can solve with logic. Otherwise, there would be no problems with politics, right? So this is what happens with LLMs also. As the models will get better, the kind of reasoning they can do is associated with the argumentation stuff. But it's not a good solution for now, because of the hallucination, basically, to solve simple problems like that are related to logic. So that's it.
Yes, exactly. That's what actually I would to say in last two slides of my presentation. I don't know how many time we have actually, unless we need to finish it already. So just to like last slide. I don't know, do we have time to run one more or I don't know?
Maybe the break. During the break we can.
Okay.
You
Okay.
can enter the data and you will continue talking and we'll just see the result.
Okay, you can. If you have any more examples to provide here.
So a puppy and a kitten.
Too much configuration.
Yeah, childhood cancer.
It's not controversial.
Okay, any of the puppy and kitten should have a cancer. Should be all.
That's a puppy and kitten.
Just puppy and kitten. Okay.
With you.
Instead of poppy,
Sorry.
poppy.
Poppy is Mac.
Yeah.
No. Puppy.
Puppy. Okay.
He did it.
This way.
Yeah.
Okay. Thank you. Kitten. Ta-da.
I'm sorry, can we make one of them Christian and another one Buddhist?
I don't know if we will not get banned by analysts for that, so you know.
Okay.
Restart the setup.
Sorry?
Restart the setup.
Puppy and the kitten on the left.
Yes. Yes, at least we have some animals here. And, okay, we have a kitten. About Poppy it will be more complicated, I don't know.
Okay.
Good enough.
Yeah. So, and meanwhile I will just tell you what I would to tell, that actually the times of generations are still very big, but we can first of all use smaller models, and second of all we can not exactly use the Raspberry Pi, we can use also some Jetson Nano, Jetson Orange, like Jetson platforms with GPU built in. Also there's some hardware accelerators, like I'm waiting for Hilo 10L, yes, maybe you heard about it. They're going to produce it in the beginning of next year, so I'm waiting to test it. They said it's built especially for generative AI actually. So
it's already launched.
Yes?
You can, yeah, right now.
Hilo 10L or 10. 10, not 8 because 8 yes, but 10. So yeah, like the 10 will be like, they say for generative AI with like 10 tokens per second, something like that, so it's could be interesting. We'll see.
FPGA for Gen AI, right?
Sorry?
It will be just a FPGA for the Gen AI, nothing else.
Okay. Well, if it works. And yes, so in my opinion, just finishing, so what do you think? The LLMs in the robots open amazing possibilities, but they're not going to replace like simple algorithms. It's still, you know, like a pilot of the fighter jet. When you need that pilot which are making complicated decisions, like thinking where to fly, which target to attack, when to return to base. But there's still a lot of like low-level algorithms which controls his ailerons, controls like that stabilizers and whatever, without which like the flight will be just impossible. So yes, in my opinion, that LLMs, they are for general reasoning, for general decision-making process, but low-level algorithms are needed for doing like simple logic stuff. And if you okay, I put it badly in the rails, I guess, but it would do, let's see.
In the dog. Yes.
The dog.
Kitten, Cooper will be less aware than the kitten. And yes, we decided to keep the dog. Oops, sorry, dog lovers.
This is the internet bias for cats.
Yes, definitely. We found it. Okay, guys, do you have any more questions?
I can just a quick one. Did you have any problem with the censoring of some models? Like, did you have to use some uncensored version, or it works with any kind of prompt? Because it seems like this could be a problem with some of the models. I don't know. Because of the alignment.
Yes, that alignment is actually a big problem. That making models safe. You know, it's crazy stuff in my opinion. It's all very hard to models.
So you didn't have any problem with that?
Yes, I mean it depends. If you will run the llama model and you will face some, more things related to, race of people or whatever, it will not make any decisions. For example. Yes, but actually that alignment of the models make them more stupid. Just fact, proven fact. Uncensored versions of the models, that's why actually I prefer to use that open chat, which is fine-tuning of our llama, which is much more intelligent than llama. And one of the reasons why is that lack of the censor. So yes, actually. Yes.
How many prompts did you need to generate to make decisions like that?
Prompts? You mean?
Just for the learning, for fine-tuning the.
You mean how many data?
Yeah.
Okay. Yes, I said that it's like for very simple fine-tuning, the 100 examples is totally enough. Yes, but yes. So to begin, it's just 100 examples, in my opinion. But for more advanced production application, it's 2, 3, 500 of examples will be needed. Okay, everything. Yes.
So, a question time. So,
yes, if you have any questions,
Thank you very much.
Alrighty, thank you very much for such insightful presentation. Right now we got some time for grabbing another beer and get some break. And after a couple of minutes, probably 10, we'll go to the next speaker who has already arrived. So take your time, start networking, and please come
Jak kolego? Dźwięk? Parę razy, ale... Czekaj. Się wywala pewnie przy zmienieniu kabla, jak laptopa zmieniali, nie?
Pytanie, kiedy argumentacje serio mają sens, kiedy po prostu w związku z działania tak naprawdę są politycznym wydaniem po prostu. Ale ja myślę,
Mam pytanie, gdzie jest HDMI?
Tak.
Okay, hello everyone. My name is Cracow Robotics and I live 60 kilometers below Krakow. So nice to meet you everyone, and I'm glad that I can present you some of my work, some of my passion. So basically, what I will try to cover today, I'll talk about the drones, the drone industry, the technical, maybe less technical details how everything works, but moreover the trends and how the drone community and technology is currently evolving. So basically, I'll try to cover everything very briefly. So if you want to ask anything specific, feel free to ask. If I will be able to answer a question, I will gladly do this. But I wanted to cover a wide range of topics in order to make it more accessible. I don't know what some people might like, might don't. Of course, I want to make it more open. So we'll see what the topic will be most interesting to you. So basically, I don't want to came empty-handed. So why I bring this with me, I'll talk about this later. But basically, it's, I think, more practical, pointing I will be doing with this little thing. So basically, I divided all presentation into three groups, like the past drones, the past technology, and how first drones came to the market, the modern drones, and what could possibly is the future. That's the basically topic for our discussion. To start the presentation, very interesting, I have a question for everyone. What do you think is more complicated, or what should I say, what is harder to stabilize? Drone of the size of a car, for example 3 meters in wingspan, or this little cat drone? The small one. I can tell you, sorry. You're right. It's basically a very simple principle, because this is much lighter construction than the one the size of the car, and this reacts much faster. Due to this fact, we have to make it all the control systems faster. So I think the discussion will be interesting. So to cover briefly this topic of the drones, let's think what I want to say. Is the drones just basically like the robots with ability to go in z-axis? That's very basic description, but it's not always this simple, because it's not enough to put one propeller on top of the robot and be happily moving in all 3 axes. It's unfortunately not this simple. And not every robot construction needs to go in all 3 axes, because when it needs, it has to be complex, very limited, and risky, due to the flight time, all the navigations, and it's not always a good choice. I mean, if somebody wants to go in the hard way, there is a way to do this in a simple sense. Just for example, that's the drone what I was thinking about. And for example, let's say we want to control the bigger drone of the size of a car. So if we have a construction this big, it's much more easier to react to all the input controls. For example, if we see the drone moving forward, we are able to manually make it go back. If he's leaning to the left, we can see and react to this and etc. make it roll to the left. And in smaller drones, this is not possible for the human to intercept this fast loop of control. So what people do in this task to solve this issue? Also, I didn't mention there is a small problems with the gravity because drone don't want to stay in one place itself. It wants to drift away. If anything breaks, for example, one of the motors just shut down, it means the drone will fall down. That's the downside of the flying drones. And the weather conditions are not likely for all the flying drones. There's issues with navigations because, for example, if we have like wheeled vehicle, wheeled robot, if we leave it in the place or tell him to go forward, we can calculate just roughly how much he go to the front, for example, based on rotation of the wheels. In the drone, it's not that simple because, for example, IMU is not enough to cover like three-dimensional movements. So that's the issues that people run into. Also, sometimes drones run into people when something went wrong, but that's we don't want to do this, right? So that's why people came out with the stabilization. Basically, how I will talk this I'll tell you about this very briefly. How the drones are working. So people want to make the drones fly. That's why they put the propellers with the motors on board to make it hover or pull against the force of the gravity. Control motors, we need ESC, this electric controller, in order to make propeller rotate, of course. But that's not enough for stabilizing our drone. Like I said, the reaction time of human is not enough at all. So that's why we need the small black box in the middle, which is the flight controller. That's basically like small PCB board with IMUs, gyros, and parameters by default. And that's enough, of course, like I didn't mention the MCU for the computing and controlling the input from the gyroscope. And the flight controller is briefly enough to make it, our construction go airborne. Basically, if we have a processor, for example, STM32, we're able to run PID loops that will allow our construction to go airborne. Also, why there is a great question why drones have 4 propellers instead of, for example, 2. This is very counterintuitive because that's requirement in order to, if you want to make the drones, if you want to control drones in all CX axes, we have to make at least 3 movable surfaces in order to make it happen. Of course, there are some drones with only one movable object. For example, MIT created a drone with only one motor, but that's more complex control, and I'll talk about this maybe later. So basically, that's our main key components if you want to make the drone fly. Moreover, people solve easily, and maybe not as easily as it sounds, problem with navigation. If we go outdoors, we are able to use GPS antenna with receiver in order to know global localization. Thanks to this ability, when people put the GPS and integrate it with flight controller, drones were able to make automatic missions. We could pinpoint waypoints where we want the drone to go, and he was able to make these simple steps in the beginning not very great, but he was able to do this. That was made around 2008 or 2006. The first drones were, of course, DIY builds, but to the market arrive very shortly some companies. So we covered simple solutions to stabilization navigation, and there were a lot of things that people didn't care of. For example, like oscillations, not enough response from the motor, from the ESC, and there were a lot of problems back in the day. So what people do, of course, they left it alone, and they solved this later. So first drones had a lot of issues with stabilization, with reliability, so that's why they crashed a lot. For example, that was very common to see a drone falling off from 60 meters. That was mostly like everyday life. And some free enthusiast builds like the Crocs one, you can believe me, this construction is able to fly, but trust me, it's not doing this great. That's why people had to solve these listed here issues. And of course, if there is a demand, the market will respond to it. So that's why in the market in early 2010, the AR Parrot into the market. That was brushed drone with a gimbal, and it was pretty much cheap. That was sold as a toy, but thanks to the SDK provided by the Parrot, we were able to import some code into it. And there were a second company that came like with very strong hand to the market, and it was DJI. Basically, almost everybody nowadays hears about DJI because that's like 80% of current drone market. And they solved very good, very simple task. First of their drones had to only hover in the place, and that was all that was needed, what was needed from this construction. And people didn't like all the downsides of the drones, so that's why they solved it in, for example, in like 8, 14 or 10 years. Basically, during this time, a lot of things has improved. For example, the motors became lighter and more powerful. Thanks to this fact, we were able to make drone more efficient, because first drones could hover about from 4 to maybe 10 minutes at first, and later they were, for example, nowadays they're able easily to go more than half an hour, and that's thanks to the efficient motors and ESC for the efficient control, because nowadays ESC have more responsiveness because they are braking, for example, motors, they can accelerate and decelerate motor very rapidly. And moreover, the switch from the lithium polymer batteries to lithium ions, which were more energy dense batteries, allow people to go about, I think right now the drones could cover even for 45 minutes. That's thanks to all these changes. Moreover, the flight computer were upgraded. The first one on the top is KK 2.0. That's the almost first commercially available flight controller, and there is no USB interface. Just a quick disclaimer: most of the current, like for example this black one, flight controllers has USB in order to configure all the requirements for the drone. For example, how much motor there is it, how big it is, and how we can tune our PID loops, for example. But back in the day, with the green one, we were able to make the cover, and that was almost like a miracle. Most likely due to poor design choices, which is interesting. For example, the gold pins that you are seeing on the top was for, I should say, 20 or 30% of the failures in the air was due to these pinouts on the green PCB because of the loose connectivity, etc. There were a lot of flight control softwares, like you can see in the top right corner. Basically, the race flight, multi-wheel, that was the back in the day, like very OG flight controllers, flight firmwares, and beta flights survive to this day, and most of the drone racing pilots are using the beta flight firmware because right now it's more reliable and responsive for quick maneuverability and fast flights with not big drones. What was upgraded also, of course, people very fast removed the LCD from the flight controller because drones are very likely to crash, and the LCD was I think the first thing that broke during the any descent, which were simply too fast. Moreover, people put faster IMUs and faster MCUs on board to make all the algorithms run 2 or 3 times faster, and it was possible to fit them even on the small drones. And for example, there is a STM F4 flight MCU on board, and if we wanted to use, for example, like F1, it would be very hard to stabilize our little guy because of the low axis inertia, and he would crash very, very fast due to oscillations and lack of ability to track his rotational movement. What also was introduced to the drone community back in the 2012 to 2016, most of the toys available in the day were equipped with optical flow. What people do, they put this very, very small and not very high resolution camera on the bottom, and they wrote the very simple optical flow recognition. And based on that sensor, people were able to make the drone hover in the areas when the bottom of the, for example, floor on the table was not even, to make optical flow algorithm possible to stay in one place, to detect any movement and shifts from the ground perspective. Also, the rangefinders were a huge improvement because now drones were exactly sure how far they are located from the ground, because early they used barometers to stabilize the height, and it was simply very, very inefficient because drone could oscillate around 2 or 3 meters in just, for example, 10 or 20 seconds. Also, the improvement was from the software side. There were introduction of the Kalman filter, and for example, the redundancy was introduced by adding additional IMUs on board. For example, right now that's the orange cube autopilot, and he has on board 3 IMUs in order to make all the flight controller more reliable and less sensitive to any errors. And that was like very good step in development. Also, current or modern, let's say, firmwares to automatic or autonomous navigations, for example, like open source, are Autopilot or PX4. I can do this later. And the huge improvement in drone industry came with introduction of SBC. Basically, the drone without the SBC is just the platform that is going to stay in one place, or if you command it to go left or the right, it is possible to do this. But there is very less things that you will do without the SBC, because right now most of the drones have like Cortex chips on board in order to process additional data. Right now, for example, DJIs, some of you might be aware that they're able to easily detect and track humans, cars, anything that you selected. And that's basically only available through the introduction of SBC on board the drone. They are not much powerful, so sometimes they rely on phone processing power, but that's one thing to consider later. So, what is possible to do when we put the SBC on board the drone? For example, the drone racing with AI powered drones. So that's a study from the UZH University of Zurich. They introduced 2 years ago one of the construction based on Jetson TX2, and this drone was able to outperform the real life top of the 2 world's best racing pilots. That was TVS Thomas and Vanover. That was like top 2 world drone racing pilot. And firstly, they achieve it thanks to beacon system. Basically, they put the cameras inside this hole to make were able to locate the drone in 3 dimensions real time. But later on, they introduced the second version of the drone with computing power on board the Jetson TX2. And basically, how this drone works. Also, we were receiving the data from, of course, IMU's barometers on board the flight controller. But moreover, they introduced the algorithm for detection the changes in environment based on camera preview. Basically, they took 2D RGB camera video feed and ran some algorithm to make detection from movements of the camera. And based on that fact, they were able to track 3D movement of the whole drone. And this drones have applications, of course, in drone racing. That's like a sports side community with delivery services and emergency response. The first usage of very rapid drone with advanced path planning and navigation are currently people trying to use it in, for example, emergency like responses from helping ambulances, transferring blood, etc. But there is no ready yet commercial ready to use drone. That's only like prototypes and do-it-yourself constructions. Moreover, on the AGH in Krakow, some guys from the famous not okay. So I'll show this later if anyone would be interested. Basically, they put the computing power outside the. Oh, that's interesting. Outside of the drone to make it able to locate itself and navigate between the racing gates. Thus, internet connection issue. And what's interesting about this drone is the computing is the place where the computing power is currently operating. For example, what's the hard thing to fit inside the drone? The drone is very not the best platform to operate because it has to be very low weight, not very power efficient because if we take more power from the drone, it means the whole platform would operate less time. And it's very easily to damage because anything goes wrong, the drone is going to crash. So that's why some people choose to make all the calculations and processing off-board and thanks to wireless connection, control the drone from this computer, which is not located on inside of the drone. But this requires radio feedback constantly. And the second approach, what like Zurich did with their drone, they put the computer on board in order to make it faster, more reliable, and thanks to this fact, they are not limited by the range of the communication. Of course, you can transfer data from, for example, a mobile network, but that's also an issue because delays so huge that drone is going to crash many times before it receives correct data. So that's for the later. And also on the AGH in Krakow, people made very simple odometry algorithm that was capturing image from camera turned upside down, turned directly to the bottom. And thanks to video feed, it was able to track the current movement of the camera. And on in the center we can see the path that is our algorithm detecting from the movement of the camera. And also it was able to make a 2D map from the all received image during this process. So that's basically another way to make a drone able to locate in 3D environment. And also, when we are able now to detect like all environments around us, it doesn't mean we are able to detect obstacles. That's another thing that people have to overcome in order to make drone, for example, follow the people, because sometimes the trees or walls are on our way to impact. Basically, what people did to make this accessible, they introduced the use of rangefinders and LiDARs on board of the drone, and later they switched to the cameras because there were some issues with LiDARs and lasers and sensors, the range of the usage. Basically, the unique drones, it was back in 2018. That was the first available commercial drone which has implemented object avoidance. But there was a catch to it. The drone was able to operate only in maximal speed of 5 meters per second, and it was due to the reaction time from the sensors that were able to catch any obstacle from 15 meters. If, for example, drone could go much faster, he would crash before he can detect that there is anything in front of him. That's why people like the Skydio companies switched to the onboard camera feed. They put 2, 3 and more cameras on board and make some algorithms to triangulate any footage from outside of the drone around it, and were able to make 2D points. You can see on the bottom right corner, just from the video feed of the cameras from the drones. And thanks to this fact that people were now able to make 3D maps and sense the environment around them, drones were able to move around and pass through all the gates and obstacles in the floor. Also, the introduction of SLAM was mandatory in order to make the drones map and be aware of this environment and what are the usage. For example, urban surveillance and inspections, and environmental monitoring, and autonomous cinematography. And that's basically the main goal with Skydio tracking. Also, there are currently on the market 3D scanning drones and drones that do photogrammetry. That's basically the key thing that was contribution to make the drones so successful. Because thanks to the introduction of very cheap way to make aerial photography, now the photogrammetry is very cost effective. Instead of flying helicopters or any aerial vehicle to photograph any area. Thanks to this fact, all the drones, for example, like Ilios on the bottom, they are maybe not the cheapest one yet, but they are very cheap to operate. For example, you can change batteries and charge it for around a few dollars instead of, for example, flying helicopter for a few minutes and paying like $200 or $300 or $1,000 per fuel, basically. And the usage of such drones for photogrammetry and laser scanning were in mining, construction site monitoring, and aerial imagery for geodesy, of course. And sometimes people like to do very accurate and nice looking visualization of the apartments. That's also the other use. Also, the introduction of SBC on board the drones allow people to put very powerful sensors on board of the drone and make the data computing in real time thanks to the SBC on board the drone. So, for example, on the top you can see the agriculture drone, which is able to make sampling of the soil in order to make to send to the cloud all the details from the particles which is detected in the earth. On the middle we can see drone which is taking samples of the air to make pretty much more accurate than sensors located on the ground, more accurate data reading from air quality or substances that is detected in the air. or basically next drone is introduced to allows us to make inspection for power lines and power stations because of the cameras that is right now that is possible to mount such drones. There are some sensors that is able to detect the current discharges, and that's right now most of the most wanted feature that people in the market are using, because thanks to the Corona camera, they are able to pick any high voltage jumps between wires and all the ports in the power stations, and this makes the drone like perfect tool for automatization of the whole process. For example, inspections and any other task that is given. Also, the constructions of the drones were not only limited to just 4 propellers and that's all. We have a lot of drones with 3, 8, 10 propellers, or even flying wings with 2 motors, and that's possible to make such platform goes vertical. That's counterintuitive because the planes should go forward instead of hover in place. But thanks to 2 surfaces beneath these motors, for example, this drone is able to move freely in all 3 axes around him. And he can, of course, switch to the horizontal flight and go fly like an ordinary plane. That was also introduced in the photogrammetry because thanks to the switching into the horizontal flying wing, we can increase the flight time by reducing our power consumption. Okay. So that's basically the brief introduction of what is available on the market and what is the future of the drones design and drones requirements from the community. Basically, right now the increasing power of all the processors is what makes all this mentioned earlier feature possible. And right now people are looking for even more powerful like computers that they want to put on board. For example, like NVIDIA Jetson or NVIDIA Jetson Ori. It's like the examples of very powerful computers that we are allowed to put on the drone. And also people are looking for vision. For example, there's similar debate for the obstacle avoidance in terms of cars. For example, Tesla and other car companies are just competing and discussing the ways to make obstacle avoidance very reliable. And that's basically the argument between only camera peak or LiDAR detection past redundancy. But right now, the vision is most cost-effective way. So if there will be any like sensors, for example, LiDARs weighs a lot for its for current possibilities. But in near future, we will see, we hope, like much more accessible sensors and also data computing. Like I said in the beginning, that's also a place to improve a lot in the drone industry, because right now the weight of the computer is what decreasing our flight time. So if we want to make like supercomputer on board the drone, the flight time is not going to be very great. And that's why the internet connectivity is crucial, but the lack of the responsiveness, the delay that is between all the system is what makes it not efficient as it should be. But thanks to the increasing frequency and increasing speeds of the internet connection, that's the near advancements that is going probably to happen in a few years. Also, the drone platforms. Right now, currently, the drone market has some leading companies, for example, like DJI, Autel, and let's say Unique. And these 3 are all China-based. We know that China is owning most of the current electronic market, but these companies are also based and owned by China. And that's the problem, for example, for American government, because the Chinese people are able to track everything what, for example, police are doing, in Poland also it's also introduced because sometimes police are using drones to monitor for example, cars that are passing on the roads, and every data that they are collecting goes to the China. So that's what we are trying to avoid, and basically the like open source and very affordable platforms at what is allowing current drone technology to improve. On the top we can see Model AI, it's Spider, I think. I might miss the name, but this drone is performing very well in the environment where there is no GPS feed because of the advanced image processing and navigation. On the bottom we can see the project that is open source from Zurich University, which introduced our drone racer. And on the bottom we can see the drone platform, that is visualization what we are trying to achieve. And basically we think that people need a very cost-effective platform, because that's what we are hearing from most our distributors, that they don't need the phone for $50,000, which crash only once and all the data is gone and they are afraid to do it again. So that's why we think the great approach that will be accomplished in the future is to make the drone similar to the Android phones. Basically makes it not totally open source, but allowing owner to make it able to do tasks that is programmed only by the companies that there is a need for it. And basically the user-friendly UI is what will make the drone very affordable and user-friendly, because right now if you want to pilot the drone, you are forced to use almost 2 decades old sticks. You can use, for example, so you have like movement from the throttle to correct when the drone goes stop and to the top and the bottom, from the left or the right in the y-axis, and we have on the right sticks we have roll and pitch axis. So basically that's what is right now available on the market, and there is a need for a very user-friendly interface. For example, people are forced to make like licenses and make the courses that will tell him how to operate such a drones, and the drones, thanks to the AI, basically machine learning and speech recognition, is very simply to make the drones navigate from their voice commands. That's what companies are trying to achieve right now. So basically we hope that this is going to appear in the near future. So that's basically the drone industry at the moment. So thank you very much for your time, and tell me if anything sounds much interesting for you. Yes.
You haven't mentioned any military drone applications.
Yeah, I try to avoid this topic because it's similar with the robotics, like all community. The military is very budget-friendly, of course, way to fund your advancements in technology, but it's also very risky, because if you give goods to every country, you are making them more. You are making this more easily for them to track anything and anything that moves. That's why I avoid it. But if you have any question what a drone look like at the moment, I could answer it, because, for example, maybe most of you could see from the viral videos that on the borders we have like cheap FPV drones carrying like huge warhead, and that's a big problem, because that's almost the most cost-effective way to deal with any targets, tanks, buildings, because they cost around $2 or $1,500 or 1,000, and could destroy the things that is worth even millions. So that's why we don't want to talk about this very, very frequently, but we can deny that is very, very common to use in the military. Yeah. So do you want to know more specific about something from the military drones, or you are just asking about is it there or they are not using it very well?
When will they be able to be both dangerous and autonomous?
I'm afraid it's very close. Basically, to be honest, there is no stopping from using military to use autonomous guiding drones, and that's basically very dangerous because right now these FPV platforms, I could show you, for example, the most FPV platforms are limited by the range of the communication. If there is, for example, the jammer, the drone is going to fall down and he's not going to do much harm. But there are already the drones current development that is able to track any target and go even if the communication is loose. But the one thing that we can do as community is shift the usage, because we can make this drone, for example, accurate and suitable to destroying, for example, the task instead hunting humans. That is it's very similar to the trolley dilemma, but that's nevertheless at least a harmful way to prepare the environment for these drones in the battlefield. So that's also the controversial way to use the drones, but it's there and there is no stopping to it, because if people see money, they can do anything, and there are a lot of companies that are currently working on it. I can say I know this from first-person perspective, because our company is also, the companies that I'm working on, is also working on similar designs, but we are, for example, making attempts to make it suitable for only like tanks and stuff that is cost-effective, instead of harming like humans and any other. So maybe like more or less controversial. I'm okay with it, but that's very hard topic because of the not very common usage.
Yeah, that's my question. You mentioned some algorithms for the drones, and what I know is that some is pretty cost effective and computational inefficient. So I actually put it as a real use cases using some production. Any example? Not use cases, any example for real drones which are using some algorithms to navigate?
Like object avoidance or just?
Let's say object avoidance or something like this. Yeah,
okay.
Some applications. Okay.
So there is a gap between automatic and autonomous navigations, and the drones that are using autonomous navigation are the drones that is able to decide is he able to go, for example, through this gap following some target, or he is not. That's basically the autonomous zones. And the first company that was successful in making the drones very cost-effective and able to avoid any obstacles were Cracow 2.0, and that's exactly the drone that is right now available in the market. But there is not a lot SDK that it is enabling you to avoid, to upload your own code and make it more suitable, for example, for any means that you need. That's commercial drones only for recording the people and going, for example, following them and making YouTube video to make it go viral. But also, for example, the DJI company, the current like Mini Freeze or Mavic Freeze have SDK that is allowing to, thanks to their interfaces, make it more programmable. But that's not yet like a very good quality. You are not able to, for example, go on board and install any software that you want, and for example, like wrote code in Linux, Python or anything else. We are just limited to SDK that is DJI provided. So currently there are some platforms, for example, like modal AI, that's like Spider, and that's a commercial platform that allows people to write own codes and uploading this to the drone. And there is, I think, 40 processors on board. And you are able to, thanks to the open source construction of the drones in the middle, that's from Zurich University, you are able to make it yourselves based on GitHub repositories.
I do know if they use anything camera filter for mapping.
Which one? Any?
Most of them, like the one is more efficient, the one more popular version.
Okay, I think that Helios might be the thing, because these drones are good at avoiding obstacles, but not for 3D mapping as well. That's the downside of such lightweight platforms. But Helios, introduced here, that's the bottom ball drone, have LiDAR tilted on the back, and that's the drone that is possible to go even into very narrow like pipelines or anything without much trouble. But the autonomy and SDK available to the people are also limited, like with DJI. So it's a good platform for mapping, but making it automatic is like very, very tough thing to do, but this is possible.
Do you know maybe by any chance number of computer characteristics? Like number of computer of the drone information stuff, like RAM requirements, that's for...
I can't recall it right now because